All right, when we get back from spring break, I'd like to talk a little bit more about impulse and momentum before we move on. And I'd really like to have some videos of you guys doing some demonstrations. So, your assignment at some point over spring break, I want you to record some example of momentum. Okay, it could be conservation momentum, it could be an impulse. It doesn't have to necessarily involve you in the frame, but if you can come up with something that demonstrates like an object's mass times its velocity, okay, or its momentum can then be transferred to other objects, or maybe there's two objects involved that start out with no momentum and then end with some momentum, and momentum is conserved. You could get creative, but here's just some ideas. And I've just been browsing YouTube and trying to find them, but a lot of them, are done by Diana, physics girl, and you've seen them before. So you could recreate some of those, but hopefully you could come up with some of your own. You don't have to film just one, but hopefully at least one from everybody. You could do the egg, throwing an egg into a sheet, which is fun if you've never tried it. Um, the double ball bounce, tennis ball on a basketball, or what's really impressive if you get one of those really really good um, like rubber bouncy balls on a basketball. You can get some serious height, so that's also fun if you've never done it. One that I'd really like a good video of would be someone standing on a skateboard and throwing an really heavy object. So if you're standing on like a frictionless surface, which, if we had skating rinks or ice rinks and ice skates, this would be a little easier. But standing on something that can roll and then toss something really heavy like a medicine ball or some other large object. Being really careful, if you throw it on the ground, you're not going to damage anything, but throw it and then film yourself, right? Conservation of momentum says you should go in the opposite direction. And probably since you have less, or like since the object that you're throwing has less mass, you probably won't move away from it very fast, right? If you throw a really light object, that's not going to give you enough momentum to like move anywhere significantly fast. Okay, but if you throw something heavy or even push off a wall, which is pretty much infinitely heavy because it's not going to move, then you could like push yourself backwards. So I don't know, getting creative with that, it would be really good to have a nice video. If you have, or would like to launch some rockets, maybe you have some and some old model rocket engines. You don't have to do model rockets or hobby rockets. If you've got like maybe one of those water, rocket toys, that'd be really cool. Um, or you come up with something to launch. Again, creativity and having fun and using what you've got is good. And then the last one I was thinking through and I just saw a cool video is a marshmallow cannon, but maybe think of it like a blowgun. And if you have, say, a long tube, this was kind of cool. You could launch marshmallows out. So mini marshmallows out of a long tube. You could use PVC pipe. You could use a roll. What I saw was a roll of paper. Okay, and they would launch it. Okay, get some maximum range. And actually, a 3 foot blowgun could shoot like one of those like blow darts or like one of those little tiny plastic pellets pretty far. Like they're pretty impressive little toys. Anyways, you start with a long tube, you measure its max range, and then you shorten the tube and measure its max range, and then shorten the tube and shorten the tube and shorten the tube, and try and apply the same force, right, with probably your breath every time. Well, if you're applying the same force but over a shorter and shorter time period, because right, it's got less time in the barrel, then you should get lower velocities and therefore lower range. And this has to do with impulse. And right, impulse was force times the time period that force is exerted. So if you exert it for less force, and that's equal to a change in momentum, it's going to have, same force, less time. You're going to have less momentum and therefore less velocity, right? Because let's say you've got constant mass. Well, then momentum is mass times velocity, and if mass isn't changing, then velocity has to change. So you'll go from no velocity to very fast velocity if you apply a force over a time, okay? Especially with like a blowgun. So you could try this. There's lots of video ideas on YouTube, but what I want to get is, instead of me doing demos, and having to run around and find all the supplies, if everybody could chip in, and I'll do one too, if everybody could chip in and film some example of a momentum change, momentum conservation, impulse, um, anything having to do with, I think it's chapter 5 in your book. So you could also skim through chapter 5 and see what kind of things there are, look at the problems. Maybe there's something you could find to recreate. And I'll try and post some links too. But just get a couple, a clip. You might have to do a couple takes to make it look good. But that's the assignment, and I'll throw some points your way. And I'd really like to show off your videos too after spring break. So, anyways, we'll talk more about this in class, and I will see you later.